In this last video for week 3, we're going to talk about how to find probability using a sampling distribution of sample means. Again, we're focused on just a sampling distribution for means. We're going to talk about other sampling distributions later. There's a step list for doing this, and the first thing you should do as a practicing statistician is check that the sampling distribution is normal. So either our sample size is greater than or equal to 30, or the original population is normal. Again, we're going to assume this is true when we're looking at problems from the book. But as a practicing statistician out in the world, you should check this condition. Because if it's not true, then you shouldn't be using the normal distribution to analyze your data. Once that's given, we're going to use the same steps that we did when we were finding a probability with a normal distribution for raw data. We're going to list the quantities that were given, our mean, our standard deviation, our sample size, and either our boundary values if we're asked for probability, or our probability percentage or area if we're asked for boundary values. And we're going to solve using the appropriate steps with the following substitutions. The mean of the sampling distribution is the mean of the raw data. The standard deviation of the sampling distribution is the standard deviation of the population divided by square root of n. And we know what these steps look like. We list the given quantities, we draw the normal distribution, we label the normal distribution, we use the appropriate function call on our calculator, and we include those steps on our paper. So let's do a couple example problems so we can get a feel for what it looks like to actually work with a sampling distribution. So first example says an unknown distribution has a mean of 45 and a standard deviation of 8. Samples of size n equals 30 are drawn randomly from the population. Find the probability that the sample mean is between 42 and 50. So let's go ahead and go through. We know that it's an unknown distribution. We know the mean is 45. The standard deviation of that raw data is 8. We know we're going to collect samples of size 30. And we want to find the probability that the sample mean is between 42 and 50. So let's go ahead and list what we're given and what we're asked for. So we know our population mean is 45, our population standard deviation is 8, and we know it's an unknown distribution. We know we're collecting samples of size 30, and that tells me that the distribution of sample means x bar is going to be normal even though my original distribution of x's is unknown. And I know that it should have the same mean that the population did, and it should have a standard deviation of the population divided by the square root of n. And then I'm asked, what is the probability that that sample mean x bar is between 42 and 50? So I'm going to draw my picture, and then I'm going to use normal CDF. Off to the side here, I'm going to jot down what 8 over the square root of 30 is to help me draw my picture. But when I do the calculator math, I'm going to leave it as an exact value, 8 over the square root of 30. So this is about 1.5. So I'm going to count by 1.5 on my picture. So our mean is 45, 46.5, 48, 49.5, and then in the other direction, 43.5, 42, 40.5, and this is a distribution of x bars instead of x's. I'm going to mark where those boundary values are. 42 is right here. 50 is right here. So I'm looking for this area here. I want to know what that area is. And I can see that that's most of the curve, so I know that I'm expecting a large answer before I ever do the calculation on the calculator. So we know to do this, we're going to call normal CDF. When I have boundary values and I want a probability, that's normal CDF. It's going to ask me for lower bound, upper bound, mean, and standard deviation. So my lower bound is 42 and my upper bound is 50 for the shaded area. My mean is 45 and my standard deviation is 8 divided by the square root of 30. So we're going to go ahead and plug that in our calculator. Second, bars, normal CDF. And we get 9797, 0.9797, which is approximately 98%. And looking at my picture, that checks out. I can see that that shaded area is most of the curve, and that I ended up with something close to but not quite 100% makes sense. Let's go ahead and try another one. So the next one says the length of time in hours it takes an over 40 group of people to play one soccer match is normally distributed with a mean of 2 hours and a standard deviation of 0.5 hours. A sample of size n equals 50 is drawn randomly from the population. Find the probability that the sample mean is between 1.8 hours and 2.3 hours. So we're going to pick through this problem again. Length of time in hours, normally distributed. So we know x is normally distributed. X is length and time. And it has a mean of 2 hours, and it has a standard deviation of 0.5. We're then going to collect samples of size n equals 50. And construct a sampling distribution of sample means. Since n is 50, and that's greater than 30, we know our sampling distribution of sample means is also normal, and it should have a mean of 2 and a standard deviation of 0.5 divided by the square root of 50. And then they say, find the probability that the sample mean will be between 1.8 and 2.3. Again, notice the wording of the question. When it says find the probability, it specifically is asking the probability that the sample mean is between those hours, not that an individual soccer match is between those hours. So that's how I know that this is x bar and that I'm working with this distribution instead of this distribution. Once I've set this up, process is the same. We're going to go ahead and draw our picture. Off to the side here, I'm going to figure out what this is just so I can kind of estimate when I draw my picture. So 0.5 divided by the square root of 50. is 0.07. So we know our mean is 2, and then this is going to be 2.07, 2.14, 2.21, 1.93, 1.86, 1.79. And then we mark those boundaries and we shade in the appropriate area. So they're asking what is the probability that the sample mean is between 1.8, which is about right here, and 2.3, which is somewhere way out here. So I'm looking for this area here, and I can already see that that area looks bigger than the area I just calculated in my last problem. So I'm expecting an answer that's even closer to 1 than our last example. But let's go ahead and set this up. So we know that we're going to do normal CDF, which is going to ask for a lower bound, an upper bound, a mean, and a standard deviation. Lower bound's 1.8, upper bound's 2.3, mean is 2, and standard deviation is 0.5 divided by the square root of 50. And we get 9977 rounded. Or 99.77%. And you can see that is even bigger than the about 98% that we found in the last example, because we shaded in more of that normal curve. We've got one more example, but before we do it, just to point that step where we're properly labeling our axis on that standard normal curve is an excellent way to check that your answer makes sense. Because we learned the empirical rule back in week 1, we understand how this normal curve is distributed. 68% is between 1, 95% is between 2, 99.7 is between 3, right? 50% in either direction from the mean. We have a rough idea of what this data is distributed like, so we can correctly assess whether that makes sense in terms of our picture. All right, let's go ahead and do one more. In a recent study, it was reported that the mean age of iPad users is 34 years. Suppose the standard deviation is 15 years. Take a sample of n equals 100. What are the mean and standard deviation for the sample mean ages of iPad users? What does the distribution look like? Find the probability the sample mean is more than 30. Find the 95th percentile for the sample mean age. So we know that our raw data, we're looking at the mean age of iPad users. Not mean age. Raw data would be age of an iPad user. We know that that data has an unknown distribution, because nowhere up here did they mention what that distribution of ages looks like. But we do know that that mean is 34, and that standard deviation is 15. We also know that we're taking samples of size 100. So for A, It asks, what are the mean and standard deviations for the sample mean ages? Sample mean ages. So they're asking, what is mu x bar? What is sigma x bar? Sample mean ages, that's what they're asking for. Mu x bar, sigma x bar. And we know, thanks to the central limit theorem, we're taking samples that are bigger than 30. We know mean is the mean of the population. Standard deviation is the standard deviation of the population divided by the square root of the sample size. So our mean is 34 years old. Our standard deviation is 15 years old divided by the square root of 100, which is 10, which would be 1.5 years old. B then asks, what does the distribution look like? And we go back to the central limit theorem. Because our samples are bigger than 30, we're collecting samples of size 100. If I build a distribution of all possible samples of 100, I should end up with a distribution of sample means that is approximately normal with the values we just stated in part A. Mean of 34, standard deviation of 1.5. Once I know what the distribution looks like, now I can do C and D. For C, says what is the probability that the sample mean age is more than 30? X bar is more than 30. And we know how to do that. We know that's a normal CDF question. So let's go ahead and draw our picture to get a sense for what that distribution looks like. So we know the mean is 34, and we're adding or subtracting 1.5 in either direction. So 35.5, 37, 38.5, and then 32.5, 31, 29.5. And I want to know 30 or bigger. So 30 is over here. I want greater than 30, so that's all of this, and I can already see, again, this is most of the curve, so I'm expecting a large percentage. But let's go ahead and do our normal CDF. I know it's normal CDF because I'm asked for a probability. Lower bound, upper bound, mean, standard deviation. In this case, my lower bound is 30, because that's where the shading starts. And my upper bound, this curve goes to infinity. And I know on my calculator, infinity is 1e99. Mean is 34. Standard deviation is 1.5. You could do 15 divided by the square root of 100, but because the square root of 100 is an exact value, this 1.5 is an exact value. We'll go ahead and grab our calculator, second vars, normal CDF. And again, we get that large percentage. We get that this probability is equal to 0.9962 or 99.62%. So if I collect a random sample of 100 iPad users, there is a 99.62% chance that the average age of that group of 100 is 30 years old or older. All right, that's the end of our week 3 material. If you have any questions on anything that's been covered, either in the videos or in the book, feel free to send me an email or drop by my office hours on Tuesday or Thursday. A reminder that if you can't manage to make it to office hours, please send me an email and we can arrange a one-on-one meeting. I will warn you that this week I am in Modesto again. I'm away from home. So make sure you give me enough warning so I can arrange those meetings. And I will be unavailable on Saturday because it's a travel day for me. Again, if you have questions, let me know. Otherwise, I hope you have a great rest of your week, and I will see you in week 4.